Greetings to you. Welcome to Engineer Construction Lecture Hub. Good evening, everyone, and happy Sunday to you. I hope you had a good day. Yeah. You're welcome to Engineer Construction Lecture Hub. This is a live streaming. I wanted to drop or discuss something very important, always as regards to construction. All right, so just sit tight as we kickstart this session. All right, and today's topic is basically how to, improve the depth of a wrongful excavated foundation trench. Now, as you know that every construction work, or mainly 95% or 98% of our construction work has to do with excavation. We have to do excavation before we can, start our construction. All right. So most times you see that depending on the kind of foundation we adopt, all right, why I said 95% of our construction, you must do excavation, except in the case of our pile foundation, where we introduce piles, down, to cut across several stratas. All right, but other types of foundation, like your strip foundation, your pad foundation, your raft foundation, all of these other types of foundation requires excavation. All right, excavation ought to be done before the construction of that structure will commence. All right, so but I want to talk about something very important today. Now, I discovered, or over time, I discovered that most of our street foundation undergoes uneven settlement. Now, if you carry out an investigation on the actual cause of some of the cracks we experience or that manifest on our superstructure, is as a result of what we want to discuss this evening. All right. Now, as you understand, most of our foundation rests directly on the soil. Okay, that is on, in terms of the surface area, there is a contact point, between the foundation and the soil. All right, we try as much as possible to create that stability, okay, by enhancing that or stabilizing the surface of that contact area. All right, now you find out that when this load is being transferred, okay, especially for example your pad foundation, you see that it is the pad footing that actually, or the pad base that actually spread this load. All right, so it's important that we create a leveled surface, okay, contact area, for effective spread of this load. Now, once there is imbalance, okay, once there is a kind of an imbalance, equilibrium is not maintained, you see that will have implication on that pad footing. All right, because in terms of the punching stresses will be also encouraged with such an uneven contact area. All right, because you see that those pads are expected to be seated on a leveled trench base. Okay, now you see that most times when we do our excavation, like the buildings we have around, they are predominantly the type of foundations that are adopted are mainly your pad foundation, your strip foundation, and in some cases raft foundation. Now you see that when you do excavation, most times there are specified depth for excavation. All right, there are specified depths, but you see that in the course of excavation, some of those that do the excavation usually go below the stipulated depth. All right, they exceed that depth that is, that is actually meant for that particular type of foundation. Now, it's important that when that happens, there are certain things that you need to do in order to improve that depth. Okay, you see that, for example, in a clay soil, once you excavate a particular soil, for example, a clay soil, it is practically difficult for that soil to be recompacted, to attain that level of compaction. In the case of clay soil, okay, it is very, very difficult. So that is why it's important that when you do your excavation and you exceed that depth and you want to still maintain that particular depth, it is not advisable to use the excavated soil and try to reintroduce it back and compact. When you do that, like your clay soil, during the dry season, the clay soil tend to be hard and it forms lumps. Now, when you now drop these lumps, this excavated soil, and try to apply some form of compaction, at that point in time, it might look compacted. But once the seasonal changes takes place, that is the wet season comes to play, you see that the swelling tendency will now make the volume of that soil to be reduced. And once it is reduced, it means that every other load, that the gravity load now will tend to respond to that decrease in volume. And that brings about settlement in our structure. And in some cases, differential settlement. So most times you see that when we have our strip foundation, our strip foundations are mainly resting on the thickness of our concrete. Okay, in most cases, plain concrete. Okay, PCC. All right, they are resting on PCC. So you see that any form of tension will bring about crack. Okay, and that crack will lead to a kind of separation. There will be that connectivity will no longer be there. All right, so you see that will bring about distortion in the substructural arrangement. All right, so it's important that when we do our excavation, we shouldn't neglect that aspect. If the depth is expected to be maybe 1.1 meter, that is 1,100 millimeter depth, it's important that you create something, a template, okay, which the people doing the excavation can take reference. Okay, they can use it to be referencing, not to exceed or go below maybe a depth of 1.3, in some cases 1.2. Okay, you see that it has gone below the expected depth. All right, and if peradventure it happens, there are certain measures that you need to take, and those are the measures that we are going to discuss tonight. All right, but I want you to understand that foundation is expected to maintain equilibrium. All right, equilibrium ought to be maintained substructurally, because most times you see that when this gravity load comes, it requires some level of balance, okay, some level of equilibrium in our substructure to be able to sustain that load and spread that load. Now, peradventure, there are lapses, okay, in the case of the substructure not maintaining equilibrium. You see that there will be some form of problems substructurally, and that will also bring about uneven settlement in our substructure, which automatically manifests in our superstructure as cracks. Okay, so it's important that we don't neglect this aspect of excavation. Whenever we are doing any construction and we are doing excavation, we must ensure that a kind of checkmate the process of excavation. We checkmate the process of excavation, ensure that the excavation does not go below the specified depth. Now, back to our topic of discourse tonight. Now, peradventure, you encounter or you have a scenario where your depth goes below the specified depth. What you are expected to do are what we will discuss tonight. Now, first and foremost, if you're faced with a clay soil, for example, all right, you know clay soil is expansive in nature and is highly compressible. All right, so clay soil requires something that will help to stabilize, something that is cohesionless. All right, something that is cohesionless, a soil that it's grain, that has grains, okay, that are free, okay, the grains are free. Example is your sand. All right, so if you're faced with a clay soil and peradventure you go below the expected depth, instead of filling back the excavated soil, okay, to gain back that depth, that required depth, it is better to use your sharp sand. Okay, you can fill in your sharp sand, to recover back that depth. All right, before you can now lay your concrete base. All right, for example, in the case of a clay soil, you see that clay soil, once you excavate a clay soil and that space is created, automatically that clay soil is exposed to hardening process, especially in the dry season. Once you excavate a clay soil, any clay soil, you see that exposed surface will be exposed to dryness, and that dryness will bring about cracks. You see some form of hair cracks, and in some cases it's even wider. All right, so to prevent the effect of that, when you introduce your sharp sand to get to that required to reclaim back that depth, you have helped to enhance that base. All right, you have enhanced that base, so it means that foundation will not be hampered. Okay, it will not be hampered because of those, in terms of maintaining a good contact area for our foundation. All right, now you see that another alternative to that is for us to use weak concrete. Okay, we can introduce weak concrete, all right, in those areas. All right, there are some cases where you have done excavation. I'm giving reference to clay soil because that is predominantly what we have in this location. All right, so that is why I'm making a reference more on clay soil. All right, there are some cases in clay soil where you excavate, you see that the coloration, if you observe the coloration of your excavated trenches, you see that there are difference in the coloration. All right, there are some areas that might look darker. All right, now this coloration is as a result of what has transpired in that section of the land. Okay, because as you know, our lands, there are some activities that takes place. All right, there are some decomposition, organic degradation that takes place. All right, now this degradation usually influences the parent soil. All right, the original makeup soil within that location is usually influenced by some of these degradation. Now, once those degradation takes place, it will influence that soil at that particular location, and you now see that most times the coloration after excavation, if you observe, you see some discrepancies, in the coloration within that location. Now, that will give you idea that you must do the needful. Okay, you must do the needful. There are some cases also where after excavation you encounter tree trunks. All right, tree trunks that are already buried that are covered already for a very long time. Now during excavation, you now encounter those tree trunks. All right. Now removing those tree trunks will create spaces there. All right, especially when you're doing excavation and your excavation runs into, that is the trench lines or the pad base runs into that that area where you excavate, you removed a tree trunk. When you remove a tree trunk that has been covered for a very long time, that tree trunk has already created a space there. All right, and that space that it has created is quite different from other parts of that trench. All right, so it is important for us to stabilize that area. All right, for us to ensure that our base is safe, it's important that we stabilize that section before we can start doing our construction work. Now we can do weak concrete. Okay, we can do weak concrete to in our trenches to give or a kind of to enhance the strength of that soil before we can start doing our main concrete. All right, so if peradventure maybe in a sandy soil, you can do your weak concrete. In some other kind of soil too, you can do weak concrete to reclaim or regain back that depth. Remember that we are looking at a scenario where we excavate below the specified depth. The context of this lecture is for us not to, in the case of a clay soil, for us not to return back the excavated soil back in order to regain back that depth. For example, I said if you're going for a depth of 1.1 meter and they ended up excavating to a depth of 1.3 meters and you want to regain back the 1.1 meter, it is advisable not to use that excavated soil to reclaim back that depth. All right, when you do that in the case of the clay soil, at that instance it will look stable because clay soil in its dry state will look hard, will look strong. Okay, but once you return it back and maybe you do some form of compaction by stepping on it or using your rammer to ram it to get back that depth. When you do that and lay your concrete base, for example, in your strip foundation, your strip foundation totally depends on the thickness of your concrete base. Now, when you lay your concrete base on that kind of compacted soil, all right, you see that over time, due to the seasonal changes, that clay soil will tend to absorb water and that will cause swelling. And when that swelling occurs, you will see there will be a decline. Okay, there will be a decrease in the volume of that soil that you have used to fill that depth. There will be a reduction in the volume. Okay, and that reduction will cause a corresponding effect on the base because the structure will exert its gravity load. All right, which is constant. All right, and that will bring about a drop, which usually result to settlement in our structure. All right, and that settlement, comes with a lot of issues, like in the case of differential settlement. And there was a lecture I did some time ago where I talked about that when your building rests on the foundation, now the gravity load tends to travel towards the weakest part of that foundation. All right, it travels towards the weakest part of that foundation, and the weakest part is where the stresses will be more, and that is where the problem will start emanating from. Okay, and I also made mention of there are some situations where you do excavation and you don't do thorough leveling. Okay, you don't do thorough leveling of the trench base. Now, when you don't do your thorough leveling of the trench base and you lay your main concrete, you discover that the contact area, there will be undulation. All right, the thickness that you expect to maintain will not be uniform due to that uneven or undulating excavated surface, base surface. All right, because concrete takes the shape, where you place it. All right, it takes the shape of where it is being placed. So if you don't have a leveled surface and you place your concrete, you see that there will be variations in the thickness of your concrete. So for example, if you're doing a steel foundation, for instance, and you're expected to maintain a 150 millimeter thickness all through the trench of that foundation, now you discover that due to the trench not maintaining good leveling, all right, you will see that there are some areas where maybe is higher. The concrete will be reduced at that area. All right, it will be reduced to maybe 100 millimeter due to the fact that the soil or the soil was not properly excavated, as in thorough leveling was not done. So basically, you see that there are some areas in our trenches that that are not thoroughly leveled. So when you place your concrete, it takes that shape, because our emphasis is at the top level. We look at the top level, in our referencing, especially trying to get a thorough concrete level. We look at the top level, but we neglect the bottom part of that concrete base. All right, and when we neglect it, you discover that as due to wrongful excavation, that normally leads to that variation, in our concrete base thickness. You see that when you eventually load that structure, especially in the clay soil, during the wet season, once it gets water, it tends to swell. And when it swells, you see that due to that variation below the concrete base, will not create some form of imbalance in our substructure. And once that imbalance takes place, definitely it will bring about uneven settlement, which is predominantly is characterized with clay soil. All right. Now, in the case of our sandy soil, most times is liquefaction. That is, if water tends to get access to it. All right. And I talked about filling with sharp sand. Now, when we do our filling with sharp sand, we must ensure that we retain that area properly. Okay, we should prevent any form of exit, because once there is any form of exit as a result of flowing water, okay, and that sand tends to erode, you see that it will expose the foundation. It will also cause some form of issues to floors. All right, there will be some form of cracks, emanating as a result of that. So basically, what we are looking at today is that we should be cautious. Okay, when we are doing excavation, we should also kind of regulate the excavation process. All right, to prevent a scenario where the people doing excavation does not go below or does not exceed the required depth for that foundation. All right, so peradventure it happens, we must do the needful. We shouldn't neglect that aspect by just a kind of throwing back the excavated soil. In the case of our clay soil, it is not advisable to return back that excavated soil and now do compaction. It is not proper, because by doing so, it will have a negative impact on the stability of that structure. All right, I said earlier that when you have such a scenario, you can either use your sharp sand, but sharp sand is better when maybe the excavated soil is muddy. Okay, it's muddy, and you kind of go below that depth, you can use your sharp sand. Now, the sharp sand will help to stabilize the base of that trench. All right, it will help to stabilize it. Then you can now do your maybe your blinding and your main concrete. All right, but in the case of even in clay soil too, there are situations you have to introduce weak concrete. I said it earlier. You introduce weak concrete. You can do a ratio of maybe 1:3:6, okay, or 1:4:8. All right, you can do it, and now fill it up in that area, okay, where the depth is below the expected depth. This is just basically to return or regain back that depth, all right, in order to maintain that uniformity in the base of the trenches. All right, so you can use your weak concrete and introduce, then you do compaction. Then there are some cases, in the case of your sandy soil, you can do cement stabilization. You can do cement stabilization to a kind of enhance the strength at that surface, because I told you earlier that the distribution of load depends on the contact area, because it is the contact area that is where the load leaves the foundation to the soil. All right, so you must enhance the contact area. All right, you must do everything possible to enhance the contact area. So like I said, by excavation and returning back the excavated soil, you are not encouraging that, you're not enhancing that contact area. That is in case of your clay soil, all right, because of its dynamic nature. All right, in that case, you can enhance the contact area by the use of your sharp sand, by doing introducing weak concrete to enhance the surface. All right, then also there are some cases you can use hard cores. Okay, if you discover that soil is very marshy. All right, what I mean marshy, predominantly pit soil. All right, pit soil are very weak. All right, if it's at the if it is shallow, you can use hardcore. You can introduce hardcore to give a kind of, to give that build up that base to receive the main concrete. All right, because that hardcore, if they are properly laid, and it should be calculatively laid such that they should be a kind of having contact. All right, that is the keying power of hardcore. All right, because if they have that keying tendency, it means that they now depends on one another to be able to absorb the stresses. All right, if you don't lay your hardcore properly, you will see that they will not perform optimally. All right, for them to perform optimally, you must lay them in such a way that they are closely overlapping. All right, such that when the pressure comes, the one on top or the one below will help to resist any form of sliding. All right, and that will now enhance the stability of that substructure. And in the case of your floor, it will help to sustain that floor. All right, so for the foundation, when you encounter, when there is a wrongful excavated depth, you can use your hardcore to recover or regain back that depth, okay, so that you can now start your foundation work properly. All right, so basically this lecture tonight is centered on how to improve, okay, to improve the depth of our foundation trenches. All right, now also there are some cases where I said earlier, when you adopt maybe your raft foundation, you see that your raft foundation will help to bridge all of these weak areas. All right, it will help to bridge all of these weak areas, so the effect will not be felt. All right. Now there are some cases also. I talked about. There was a site where we encountered tree trunks. All right. Now when we excavated, when we pulled out this tree trunk, it has already developed a deep pit. All right, because that site, when they did felling of trees in that location, all right, the bulldozer tends to, you know, pull all of these tree trunks towards a particular area within that location. And now over time, the debris now covered those tree trunks. All right, and it stayed there for a very long time before the construction started. So during excavation, there are so many tree trunks that were kind of excavated out. Now that is when during the process of removal of those tree trunks, there are areas created, deep pits created. All right, now when you have such a scenario, you must look at your design, especially in situations where the line of your excavation falls along those areas, or maybe where you intend to have your column base, okay, also is situated in one of those pits. It is important that we don't neglect, we don't go ahead and do our reinforcement and concrete works. We must fortify that area. We must do some form of works there before we can now start the construction proper. Otherwise, once that structure is loaded, because as you know, when we are doing our construction, at that substructural stage, that structure is not fully loaded. Understand this fact. When we are bringing out our structure from the foundation, all right, as the structure is coming up at that DPC level, the structure is not full, or the soil has not fully received the magnitude of load from that structure. All right, it has not received it yet. It is when the superstructure comes on it, that is when the cumulative effect of the load will be felt substructurally. All right, so it is important that we fortify the soil, okay, before we start loading it. Okay, that is also the reason why in some cases, in some soil makeups that seems to be weak, it's important to adopt frame structure. We do frame structure. Now frame structure is basically you do your substructure, that is your foundation, then you now project your columns. All right, you project it. Like I said, at that point the soil is not fully loaded. Okay, it's not fully loaded. So when you do your foundation, you project your columns, you run your beams and maybe your slab. You get to the first floor, you project, maybe depending on the number of floors you go, as in the case of a frame structure. At that point, you see that the load, okay, the magnitude of load that is being exerted on the soil is not at its maximum. Okay, is not at its maximum. So if you are adopting such, it is good, depending on the nature of the soil, because there are some soil it's advisable for you to go on frame structure. Okay, you go on frame structure, then at the end of the day, you can start doing your wallings and all of that. All right, then there are some cases where, like I said, clay soil is very dynamic. It is being influenced by the seasonal changes. All right, now there are some cases where when you build, okay, on clay soil during the dry season, you think that the soil is very stable. Okay, it's very deceptive, and that is why you see some persons, they will just do a depth of maybe 600, 300, 450 depth, and they start pulling their structure from there. Especially there are some bungalows that lies, okay, that rest on a strip foundation at a depth of 300, 450 depth, okay, you see that such a depth is not even good for such a foundation, because only vibration from a nearby vehicle, trucks, actually if the structure is built close to, areas that are developing, all right, areas that you have untarred roads, all right, you have untarred roads, and there are trafficking of a kind of heavy duty trucks. You see that those trucks tend to the effect of that movement, okay, is usually transferred to the nearby structures, nearby foundation, and that alone can affect shallow foundations. All right, so that is why you see some buildings close to untarred roads, having the problems of cracks. All right, especially those structures that are resting on strip foundation, they are prone to cracks because of the effect of vibration, the resonating effect that is being caused by these vehicles, these heavy duty vehicles that applies on tarred road. Remember, in our road construction, we have different layers, especially in the case of our flexural members, flexural pavement. Okay, flexural pavements are made up of different layers. The subgrade, we have the sub base, we have the base, we have the wearing cores, in that the binding and wearing cores. All of these have their various functions in the flexible pavement. Now, cumulatively, they help to reduce the effect of this load from our vehicles. All right, due to these various layers, the pressure, the pressure from, or the stresses from these vehicles are reduced as the stresses goes down as a result of these various layers that makes up our flexible pavement. That is in the case of our roads. All right, so it is quite different from untarred road, a virgin ground, all right, where vehicles ply, especially in a developing areas where you have trucks that brings in materials like your granite, your sand, and all of that, plying that untarred road. You see that the impact will be felt more on the nearby structures. But if it is a tarred road, that, a flexible pavement, you see that the pressure will not be much as a result of these various layers that makes up the flexural pavement. All right, so we must understand the dynamics in these formations. All right, so generally we must maintain equilibrium when it has to do with our foundation. All right, because once equilibrium is not maintained substructurally and the structure is being loaded, you see that there will be problem. All right, there will be problem. Now, in some cases, you see that when our substructure is monolithically connected. Now, what I mean monolithically connected is in a case where all the components are connected as a unit. Okay, once they are connected as a unit and there are form of movement, okay, settlement, you see that the entire structure will be going at the same pace. All right, they will be going at the same pace. But in a case where they are not monolithically connected, definitely there will be differential movement. All right, there will be differential settlement, because, there are some factors that, instigate differential settlement in structure, which I've also highlighted, in the case of untarred roads and all of that. The vibratory effect, that usually goes to the foundation of nearby structures, especially if they are resting on a very shallow foundation depth, like 300, 450, 600, as the case may be. You see that the impact will be felt more. All right, then the kind of foundation you adopt too, all right, to help to minimize the effect of this vibratory effect from vehicles plying on tarred roads. All right. Now, I want you to also understand this, that when you do excavation, all right, when you do excavation, ensure that you regulate or check the process of excavation. All right. Ensure that they don't go below the specified depth. All right, because due to the zealousness, overzealousness in the aspect of those that do the excavation, they tend to do it the way they like. Okay, but if they are thoroughly monitored, you see, they will have to do it, rightly. Then at the end of the day, you must also do leveling. You must do leveling, thorough leveling. Now that leveling will help to create uniformity in the entire trench of that foundation. All right, it will create you do thorough leveling of that foundation, so that at the end of the day, when you're doing your concreting, you'll be confident that your concreting will maintain uniform thickness. All right, because when we are doing our concreting, we don't usually pay attention below the concrete base. Our emphasis is on at the top, trying to maintain top level, okay, of our concrete base where we are doing our concreting. That is when we are doing casting. Okay, during concrete placement, we usually pay more attention to the top level, ensuring that the top level is uniform. All right, but in a case where the base of your trench is undulating, you will discover that there will be variations in the thickness of that concrete base, because the soil will tend to displace the concrete, thereby reducing the depth, the thickness of that concrete base at that particular section that is not thoroughly leveled. All right, and that will become a weak spot along that foundation trench. That will become a weak spot along that foundation trench, because if the structure is loaded, now the side that maintains thickness will tend to perform optimally more than those areas that the thickness is being displaced because of not maintaining thorough level. You see that area will become a weak spot, and if anything is happening substructurally, it will begin from that area, because that area the thickness has been reduced. Okay, and once the thickness is reduced, it means that it will not perform optimally. All right, it will not perform optimally. So we must pay attention critically to our substructure. Our foundation is very, very important, because the longevity of our structure is dependent mainly on the solidity of our foundation. So we must try as much as possible to ensure that we do the needful at that stage. That stage looks very taxing. All right, the substructural works in our construction is very taxing. All right, and most cases you see that negligence, okay, to certain issues are usually felt or being observed at that stage in our construction. So the essence of the lecture tonight is for us to do the needful whenever we encounter such a scenario where we do our excavation below the required depth, and we want to regain or regain back that depth. Okay, we shouldn't use the excavated material to backfill, if I might use that, for a kind of to make it quite understandable. All right, to backfill with the already excavated soil. All right, it is wrong. It is wrong, because when you do that, you're not helping the foundation. All right, because time will come when that soil will reduce in volume. All right, there will be decline in volume, and once there is decline in volume, the structure will tend to respond to that decline, and that will bring about differential settlement in our structure. So we must try as much as possible to ensure that we do the needful. When we do excavation and we want to reclaim, we can introduce our sharp sand. In the case of a muddy clay soil, we can introduce our sharp sand. We can use hard cores, okay, to regain back the level. Okay, we can also do stabilization. All right, in the case of sandy soil, we can do stabilization. All right, we can also kind of enhance that by the use of weak concrete. We can do weak concrete, introduce it, spread it. If possible, we can, compact it. We can use our rammer to, compact it. Now, when you have done that, you have created a good contact area for the foundation base, because it is the contact area that the load leaves the foundation to the soil. So when you have a leveled, uniform contact area, it will enhance the process of the spread of load. Okay, because in the case of our pad, it is the base, okay, the area of that base that enhances, that is the area where the load leaves the structure to the soil. So we must enhance that area, that contact area. We must do everything possible to ensure that that area is stable. All right, and I also made mention of, there are some cases we find out that the area of our column base is located in maybe that area is a made-up soil. All right, there are some cases we have made-up soil. Maybe what I mean made-up soil is an area where previously they excavated it, and maybe they are throwing debris, okay, into it, throwing in refuse. All right, and it keeps on piling up, and it gets to the top, and that area, is abandoned. All right, and probably they go to another area, do the same thing. All right, now peradventure, you now do your excavation work for the construction, and it falls, maybe your column base falls into such a location. There are certain things you need to do, otherwise that will pose a negative impact to the stability of your structure. All right, most of these things are neglected aside, and that usually have a negative impact on the totality, that is the functionality of that structure, and it is usually the client that normally bears the brunt. All right, because once these things are neglected and the needful is not done, it is usually the client that feels or bears the brunt. All right, but basically I want us to have that consciousness and pay critical attention when we are doing our excavation. We ensure that we maintain level after excavation. We maintain leveling. Ensure that if you are doing your pad foundation, do your cuttings. Let there be thorough carving of that base, because in some cases we don't use formworks, because ideally for us to achieve a certain specified thickness of base, in the case of our pad foundation, there is need to use our boards. Okay, we use our formworks around that base. So when we do our concreting, we'll know that we'll achieve, if it is 300 millimeter thickness of base, with our formworks we can be able to achieve that. But in a case where we do our excavation, and for example, in our pad foundation, the area where we have our pad base are usually lower than the depth of the trench. Okay, it's usually lower than the depth of the trench. All right, now when you're going down, you must create that 300 down. All right, you create that 300 down, because it is the wall of that excavated area that will act as your formwork. all right, it will act as your formwork. So it's important that once you get that depth, you try as much as possible to trim the sides. Ensure that you carve out the area, I mean the length and the breadth. You carve it out thoroughly. Okay, you can delegate maybe one of the persons that carried out the excavation to do thorough carving of those areas for the base. Okay, they ensure if it is 1.2 by 1.2 base, they should ensure that they carve out that 1.2 by length and by width. The 1.2, they carve it out. The reason is that the wall of that excavated trench will act as your formwork. You don't need to introduce any boards or any form of formwork, to achieve that depth of thickness and also to maintain that area. The reason why I'm emphasizing on this is that it is that area that helps in the spread of our load. All right, so if you give it the right area, you discover that the spreading of load will be enhanced. All right, so it's important that we don't ignore all of this, because collectively all of these have a direct impact on the well-being of our structure. All right, so we must do the needful when we are doing our substructural work. All right, because most of the negligence has cost so much. It has cost so much to our structures. All right, because the superstructure depends totally on the substructure. So whatever we do in our substructural works, will tell how that structure or that building will perform. All right, because we don't just build for the structure to stand. All right, we don't just build for a structure to stand. We build for that structure to last. We build for that structure to be stable, for that structure to be durable. All right, these are the guiding principle that governs our structure. So we don't just build our structure to stand, because there are some persons, they tend to compromise in terms of the use of materials and all of that. They'll say, okay, I'll just erect this structure, and hand over the keys to the client, and they will hands off that structure. All right, there are some persons that does that. At the end of the day, it is the client that bears the brunt. All right, it is never a good practice. So we must try as much as possible to do the needful, especially at the foundation stage. All right, so basically, if we do excavation and we do it wrongly, all right, for us to recover that depth, okay, we can introduce our sharps, and in case of clay soil, we can use weak concrete, we can use hard cores as well, to get that level before we can start our concreting works. All right, so I want you to also understand that most times you see that our structure, especially in the sandy soil, okay, tends to tilt. All right, there are form of tilting that takes place in our structure. It is not a common phenomenon. All right, this tilting is predominantly experienced in areas where there are a kind of land reclamation, okay, where they carried out land reclamation. What I mean land reclamation, where they did a kind of sand filling of a particular area. All right, now most times you see that if those areas are close to coastlines, okay, and there are dredging activities that takes place, all right, these dredging activities usually have a direct impact on structures that are built along or close to those areas. So that is why it's important before you site your dredging equipment, you must do what we refer to as EIA, environmental impact assessment. You must analyze, you must carry out analysis of that area, okay? Understand the implication of that activities with respect to the nearby structure, all right? Because by carrying out that activities, okay, you discover that your a kind of dredging activities tends to, kind of displace quite some volume of sand, below the water level. That is the bed of, maybe it could be a stream, it could be a river, it could be any water channel, okay? So long as you're pulling out that water and sand, you're lowering the depth of that water body. And that activity also have impact on structures that are nearby, because once you create a space, automatically pressures will be acting towards that space that is created, all right? And that pressure will bring about lateral movement, okay? There will be some form of lateral movement, all right? Now, this lateral movement have direct impact on our structure, okay? So depending on the depth of your foundation, that will also have its impact on it, all right? So that is why most times when we are carrying out construction in some areas, we must try as much as possible, especially if the magnitude of load and the bearing capacity of that soil is extremely low, we must adopt pile foundation to enable us transfer the load, down to a more stable strata, where at that strata, most of these activities will not have any impact on the structure, okay? It will not have any impact on the structure. So before we carry out our construction, we must analyze analyze the soil, profile, come up with the ideal foundation for that structure, okay? Basically, this is quite distant from the topic of discourse today, all right? But I deem it necessary to throw light on those areas so that generally, let's have that consciousness of paying attention to details. There shouldn't be any form of negligence, in the course of our construction, especially our foundational works, all right? So, like I said earlier, if we are doing an excavation, we shouldn't, for us to regain back the depth in areas where it is wrongly excavated, all right? It's important for us not to fill back the excavated soil, and then compact. We shouldn't, all right? Because that area will pose a weak spot in our foundation, okay? It will pose a weak spot in our foundation. We can enhance that area by the use of weak concrete. We can also introduce our sharp sand. We can get our sharp sand to recover that depth before we can lay our main concrete. Then we can also use hard cores. We can lay hard cores to regain that depth before we can start up our concrete works. All right. So these are some of the measures we can adopt when we want to improve the depth of our foundation that is wrongly excavated. All right. So please, if there are questions as regards to the topic of discourse, you can also drop your questions at the comment section. There are contributions as well, okay, based on your opinion, all right, as regards to the topic, because it is your viewing point that determines your point of view, all right? So from your own perspective, as regards to the topic of discourse, you can also drop your own view, okay, at the comment section. All right, so I intend to stop here for today. Please do well to continually stick to Bengineer Construction Lecture Hall. I intend to be coming up on live session to discuss some critical issues, that pertains to construction. Basically, is to enhance a better built environment, because most of these issues, we have structural failures in our structures. All right, we have to start coming up with solutions. All right, coming up with measures to help to curtail these defects, okay, in our structure, so that it will not pose threats to the occupants. All right, because there are some cases we hear failures, collapse here and there. All right, these are associated to some of these issues that we are discussing. All right, so as we go on, I intend to be coming up on live sessions to exhaustively discuss some of these topics, because I discovered that most of the videos I post, they are short. Those are reels. They are reels. Reels are short videos. So just understand that you can access the full videos on my timeline. All right, you can access the full videos on my timeline. Those reels are in parts. Okay, when you look at the title and you see parts, okay, when you trace those, or better still, you go to the playlist. There is a playlist that contains all of those that particular video. In that playlist, you can access the full video. All right, so I deem it necessary to bring this so we can be able to know how to access the full video of my profile. All right, so thank you so much. I appreciate every one of you that have been that has been following all this while. Thank you so much. I intend to come up with some other interesting topic, as time goes on. So thank you so much for your time. Do have a wonderful day. God bless you richly. Thank you, and do have a beautiful night rest. Thank you. Bye.